Okay, student. This is now. Let us see question number 12. Question number 13. Yes. Question number 13 is given. See here in down. What is given that? So question number 13. Question number 13 is given a block code. Yes. Given that there is a block code. Okay. So block code of n.k. This is given as 7,4. Okay. So linear upper bound. So what is the minimum distance? D minimum. He is asking. What is D minimum? What is this D minimum? What is the exact meaning of this D minimum? Do you know what is block code? See, first of all, D minimum. What is this D minimum? D minimum is the minimum distance, or you can say it as humming distance. What humming distance? Humming distance. Yes, D minimum is the minimum distance or humming distance. Humming distance which determine the error error control error control capability error control capability of what? Block code. Okay, block code. So this is what humming distance. D minimum is nothing but it is the humming distance which determine the error control capability of block code. Okay. So now see here, what is this actually block code? Here is my message. Okay. I am giving here message. This is my message. Okay. So message of what? K-bit message. I will apply this to what? Channel encoder. Channel encoder. Here at the output I will get block code. What? Block code one. So which is nothing but here channel encoder. When this message will pass through this channel encoder, at the output I will get block code, which is a nothing but combination of what? This is my n. Okay, so this is block code. Total number of bit in this block code is n bit. Okay, n bit, and this n bit is nothing but parity bit. If you see here is a parity bit and message bit. Okay, so this n bit, total n bit means n is equal to p plus k. Yes, p plus k. P is what? N minus k. What is this p? P is parity bit. Okay, number of parity bit. This is my parity bit, or you can say check bit. Yes, check bit. Now this is what? This is my block code. Okay, so now how to determine this D minimum? See, D minimum, maximum number of bit. Okay, first of all, you see here maximum number of bit that can be corrected. Here maximum number of bit that can be corrected. See, maximum number of bit that can be corrected. So, okay, student. So this is maximum number of bit that can be corrected. Is D is what? That can be corrected up to D minimum minus 1 by 2. Okay, this is what? TC, error correction code. If you see in block code maximum number of bit that can be corrected is single. It is a single error correction. Okay, so single bit error correction code. What? Linear block code. Okay, if you want to correct more than one bit, then we have to go for other code like cycle code, like convolution code, turbo code. Okay, so where we can correct more than one bit. So it is just humming code, or this linear block code is what? For valid only for single error correction code. It is a single error correction code. Okay, so the maximum number of bit that can be corrected. Okay, this is up to d minimum minus 1 by 2. Okay, this is number of bit. How many we can correct? Up to 1. Up to 1. Okay, so then what should be the d minimum? What should be the humming distance? D minimum is nothing but humming distance. What it will tell us what it will tell us? It will determine what? It will determine the error control capability of linear block code. Okay, so therefore this d minimum minus 1 by 2 is greater than equal to tc. What? Greater than equal to tc, then this d minimum, what? D minimum minus 1 is what? Greater than equal to 2tc. Yes, 2tc. So this d minimum is greater than equal to 2tc plus 1. Okay, 2tc plus 1. Remember this one, 2tc plus 1. So therefore minimum distance is how much? 2tc plus 1. Okay, so then after that tc. Yes, tc, number of bit that can be corrected. How many? 1, because it is a single error correction code. Okay, so tc is equal to 1. Just put here tc is equal to 1. You will get d minimum greater than equal to 2 into 1 plus 1. So this is what d minimum is greater than equal to 3. So this is what d minimum is at least 3. Okay, so you can say d minimum is equal to what? 3. Okay, d minimum equal to 3. If you don't want to write d minimum, then you can write d at least 3. If you will write d minimum, then d minimum equal to 3. Okay, equal to 3. It may be greater than 3. Okay, so this is what minimum distance required for what? Single error correction. Okay, so single error correction is how much? D minimum equal to 3. Okay, in case of linear block code. Okay, linear block code. What is this d minimum? Is nothing but it is a humming distance. What? Humming distance, which determine what? It determine the what? It determine the error control capability of what? Linear block code, of this linear block code. Okay, so this is only where n is what? N is the number of bit. Okay, which is a combination of check bit, or you can say pirate bit and message bit. Okay, pirate bit and message bit. That pirate bit is nothing but difference of this n minus k. Okay, if you see here, n is what? 4 and k is equal to 4. Then what is check bit or pirate bit? That is n is 7, n minus k. Okay, which is nothing but 7 minus 3. 7 minus 4 equal to 3, means 3 check bit is required. Okay, 3 check bit is required here in order to make this message, okay, uninterrupted when we will pass through channel encoder. Okay, this is block code. Okay, so this is, therefore the answer is 3. For this answer is 3. Okay, so d minimum is 3. So and another for you can say also for error means error correction. This is for error correction, and for error detection purpose. For error detection, what is the d minimum for error detection? See here, for error detection, for error detection also you will see this. For error detection, d minimum minus 1. Okay, error detection, d minimum minus 1 is greater than equal to td. Okay, td, error detection, this d minimum is equal to td plus 1. Okay, so this is minimum distance for error detection purpose, and this is minimum distance for this tc 2tc plus 1. So this is minimum distance for error correction purpose. Okay, error correction purpose, and this is d minimum for error detection, and this is d minimum for error correction. Okay, so error correction. Here how many bit you can detect? We can detect 2 bit. Okay, so here through this block code or humming code, we can detect 2 bit. Okay, 2 bit in an error, and we can correct only single bit. Okay, we can correct only single bit, but we can detect 2 bit. Okay, so therefore d minimum is what? D minimum here is 3. Okay, so d minimum here is 3, and therefore answer is 3. Okay, so you just remember these two. Okay, so these two, D minimum for error correction purpose is 2tc plus 1 and D minimum is equal to TD plus 1. That is for error detection, error correction. Correction we can make single bit, okay, we can make single bit error correction, or we can make what 2-bit detection, okay, 2-bit detection, which detection means 2 bit are in error, okay, 2 bit are in error, that can be determined by D minimum. Here it can correct only single error, it can detect two error, detection 2 error and correction single error, okay. So that we will get in case of block code, or you can say humming code, okay. So therefore if you want to correct more than one, then we have to go for other code like cyclic code, convolution code, turbo code, okay. So where you can correct more than one bit, okay. So this is the answer for question number 13. Thank you.